Hello students, so let's try to solve one more problem from DJ Griffith, and this is question number 2.14, and this is again from the harmonic oscillator. This is a wonderful problem. What is this problem? So it is given the particle is in ground state of harmonic oscillator with angular frequency omega, and suddenly what is going to happen? The basically omega is changing and it is going to change from 2 omega. So this is the sudden process, and it is also given that psi will now evolve differently because the Hamiltonian has changed. So psi will evolve differently. What is the probability that measurement of energy would still return the value h cut omega by 2? This is the first one. And what is the probability that it will get h cut omega? So we have to find what will be probability once we are just shifting this particular angular frequency. Then students, what will happen? Whatever the initial wave function, that will remain intact because this is a sudden process, and now my particle will be into the ground state of new harmonic oscillator because omega is going to change. Once omega is going to change, then obviously each and everything of the wave function, energy eigenvalue, all things are going to change. So let us try to go for this particular problem. So we have to use the postulates, but you have to use postulates in a very smart way. So how we can go for this particular postulates? So what we have now our frequency. So initially my potential is Vx, and that value is equal to half m omega square x square, and obviously x is from minus infinity to plus infinity. So initially my particle is in ground state of this potential, so I can write the wave function is simply m omega upon pi h cut to the power 1 by 4 e to the power minus m omega x square upon 2 h cut, and x is between minus infinity to plus infinity. And what will happen? Suddenly the omega is going to change. So once omega is going to change, so the new potential, let us assume this is V dash, and the new potential is half m, this will be 2 omega whole square x square. This is my new potential, and we have to just when we are going to calculate all other things, what are the energy eigenvalue related to this new potential? The energy eigenvalue is equal to n plus half, that is h cut omega dash, and this omega dash is nothing but n plus half h cut into 2 omega. Now what are the possible value of energy? The possible value of energy is here h cut omega, 3 h cut omega, 5 h cut omega, and so on. So if you are getting the probability that h cut by 2 omega, once you are changing this particular frequency, then obviously probability of getting h cut omega by 2 is equal to 0 because it is not going to be measured. So question is very sensible because you can find only this value of energy, and they are asking what will be the energy of h cut omega by 2, and that is for the old system or old harmonic oscillator. Now the Hamiltonian is changed, so you can have this particular value. Okay. Now the second question is that what will be probability such that energy is h cut omega? So we have to calculate this one. So now this h cut omega is for n is equal to 0. So we have a new ground state energy, that is h cut omega, and this associated energy eigenstate we can find. So what is my psi? My psi will remain same because it is sudden process, and that value is m omega upon pi h cut to the power 1 by 4 e to the power m omega x square upon 2 h cut square, where x is between minus infinity to plus infinity. And what will be my ground state of new system? The ground state of new system is m 2 omega upon pi h cut to the power 1 by 4, and here minus m 2 omega x square upon 2 h cut square, where x is between minus infinity to plus infinity. And what will be my probability, and the energy associated to this one is h cut omega. So we can easily find the probability. So finding probability of getting h cut omega is basically we have to calculate psi naught star psi integration dx minus infinity to plus infinity square. So this is my probability such that we can get this particular value. So when we are going to calculate this one, so this value is equal to 2 to the power 1 by 4, and all this normalization constant is there, m omega upon pi h cut to the power 1 by 2, and inside this integration phi naught star and psi, so this will be e to the power minus 3 m omega x square upon 2h cut dx, and we have to go for minus infinity to plus infinity mod square. So when we will going to calculate this one, we have to just go for basically gamma integral, and we can easily calculate this one. So I can easily calculate it. So I am just using this space. So this value is 2 to the power 1 by 4 m omega upon pi h cut to the power 1 by 2, and this integral is 2 into 1 by 2, and value is basically 2 h cut upon 3 m omega to the power 1 by 2, and you have gamma half, and gamma half is equal to root pi. So this 2 and 2 will cancel, and what we will get? We will get m omega and h cut is cancelled, and root pi is also cancelled. So we have to take the mod square of this one. So you have 2 to the power 1 by 4, and we have root under 2 by 3 mod square, and we will calculate, you will calculate, that will be 0.94. So that means 94% chance that particle will get energy, that is h cut omega by 2. So it's a wonderful problem. Why it is wonderful problem? Because you have to understand a sudden change. You have to understand all about the sudden change when you have some change in the parameter. So this is the current trend that people are changing parameter, and then they are seeing that what is going to happen. And this change, whether it is sudden change or slowly change, onto that basis you can use the postulates. Thank you.